Welcome to Bite-Size Data Science. In the neural network example in video 24, we saw that we had to deal with character attributes and convert them to numerical values. Let's take, for example, the marital status. It consisted of three possible values: S for single, M for married, and D for divorced. We could simply replace those values by the number 1, 2, and 3. This is one way to encode a categorical value. Simply have a different number for each possible value. There could be situations where a number could imply the importance of the attribute value. There is another simple representation available called one-hot encoding. It is simply using a vector that contains as many zeros as there are choices, with the exception of one position that has a 1 to represent that specific category. In our previous example, we could have used the following encoding using a vector of three values. This type of encoding is also used to represent the classification choices as the result of a neural network. So, if you hear one-hot encoding, simply think about that array of zeros with 1, 1 in it. What if you are dealing with words? In that case, you want to convert the words to numbers. A standard approach is called hashing. In English, printable characters are represented by a number between 32 and 126, as shown in the ASCII table here. A hashing algorithm may add up all the character values and take the remainder of the division by, let's say, 29,989. The key is that a word gets translated into a somewhat unique number. Depending on the upper limit you pick, you may get some words mapping to the same number. How do you pick that limit? It should be a value greater than the number of distinct words you have in your document set. It is often recommended to use a prime number as that upper limit. What if you want to encode all the words in a document? This is where the tf-idf encoding comes in. Let's start with the TF part. This stands for term frequency. The first step is to make sure that all the words use the same case. We don't want to have the same words seen as multiple ones. Then we can hash the words to their numerical value as we've seen before. The term frequency part is to count how many occurrences of each word we have. Since our encoding uses 29,989 entries, we end up with a vector of that size where most entries are likely zeros. We can use a more efficient representation called a sparse vector, that is a set of pairs of values where the first value is the hash code and the second one the number of times that value is found in the document. Any word with a count of 0 simply does not appear in the vector. Also, by keeping the entries sorted by hash values, it is easier to find similarities between documents. This brings up another concept: stop words. There are some words that you find in just about any document. They are so common that it could overwhelm the comparison between documents. In the short sentence we looked at, we had the word "the" twice within 9 words. When comparing documents, it makes sense to eliminate these stop words. We can start from a fixed list, or we can dynamically eliminate words that are not significant. This is where IDF, or inverse document frequency, comes in. IDF is a measure of how many documents include a specific word. Specifically, IDF is the log of the number of documents in the repository divided by the number of documents that include this word. Let's look at a few examples. If I have 9 documents in a repository and 3 of them include a specific word, the IDF of that word is the log in base 10 of 3, which is 0.47712. On the other hand, if I find a word in my 9 documents, I get the log in base 10 of 1, which is 0. So the closer the ratio gets to 1, the closer to 0 the IDF is. If we use both TF and IDF, we get the TF-IDF encoding value that is calculated as the product of TF and IDF. So, if the word "the" is found 10 times in a document, but is also found in all the documents in my repository, I would end up with a TF-IDF value of 0. Back to our document comparison, we see that if we use a TF-IDF value of words, we get the word frequency weighed by how important they are at differentiating documents, and stop words that are found everywhere are effectively removed. We've covered a lot of terms in this video: one-hot, hashing, term frequency, stop words, and inverse document frequency. Next time, we'll look at how we can apply this knowledge to document classification. See you next time on Bite-Sized Data Science, and don't forget to subscribe.